One of the most pressing environmental problems over the last century has been the depletion of the ozone layer. But what is the ozone layer? Why does it matter? What are causes for depletion of ozone layer? What type of rays ozone layer absorb? Where it lies on the Earth's atmosphere? Do you want to know the reasons? Let's start. Ozone is a gas present naturally within Earth's atmosphere. The Earth's atmosphere composed of 5 layers, starting from ground extending upward. 1. Troposphere. We humans live in this troposphere. Most of the mass, about 75–80%, is in this region. Most of the clouds are found in this region, and it is the lowest layer of Earth's atmosphere. It extends upward to about 11 kilometers. 2. The next layer is called stratosphere. Here, ozone molecules absorb high-energy UV light from the sun, converting UV energy into heat. Stratosphere extends to about 50 kilometers above our planet. Commercial jet planes fly in the lower stratosphere. 3. Above the stratosphere is mesosphere. It extends to about 80 kilometers above our planet. Most meteors burn up in the mesosphere. Here, temperature is minus 90 degrees Celsius. 4. Above mesosphere is thermosphere. High-energy X-rays and UV radiation are absorbed from the sun in the thermosphere. Temperature range is 500 to 2000 degrees Celsius. 5. Exosphere. Uppermost layer of our atmosphere. Ozone layer lies in between troposphere and stratosphere. Good and bad ozone. Ozone close to the surface is called tropospheric ozone, and it is often referred to as bad ozone. Why we call the troposphere as a bad ozone? Ozone concentrations close to the Earth's surface can be temporarily locally higher because of emissions from motor vehicle exhausts, industrial processes, electrical utilities, and chemical solvents. These can negatively impact human health. Breathing ozone is particularly harmful to the young, elderly, and people with underlying respiratory problems. Good ozone is found in the upper part of the atmosphere called stratosphere. It plays a crucial role in keeping the planet habitable by absorbing potentially dangerous ultraviolet radiation from the sun. Ozone depletion discovery. The ozone layer was discovered in 1913 by French physicists Charles Fabry and Henri Buisson. Solar radiation includes visible light, ultraviolet light, infrared, radio waves, X-rays, and gamma rays. Anything above 700 nanometers is long wave, and below 700 nanometers is short wave. Short wavelengths are dangerous. Measurements of the sun showed that the radiation sent out from its surface and reaching the ground on Earth is usually consistent with spectrum of a black body with a temperature in the range of 5,500 to 6,000 K, except that there was no radiation below a wavelength of about 310 nanometers at the ultraviolet end of the spectrum. It was deduced that the missing radiation was being absorbed by something in the atmosphere. Eventually, the spectrum of the missing radiation was matched to only one known chemical ozone. The ozone layer absorbs 97 to 99% of the sun medium frequency ultraviolet light, which otherwise would potentially damage exposed life. Causes of depletion. In 1976, atmospheric research revealed that the ozone layer was being depleted by chemicals released by industry, mainly chlorofluorocarbons, CFCs, man-made organohalogene compounds, and radical catalysts, including nitric oxide, nitrous oxide, hydroxyl, atomic chlorine, and atomic bromine. Chlorine and bromine radicals are liberated by the action of ultraviolet light, each radical breaking down over 100,000 ozone molecules. The breakdown of ozone in the stratosphere results in reduced absorption of UV radiation. Consequently, the dangerous ultraviolet radiation is able to reach the Earth's surface at higher intensity. Ozone levels have dropped by a worldwide average of about 5% of Earth's surface. Around the North and South poles, much larger seasonal declines have been seen and described as ozone holes. The ozone holes are actually patched in the ozone layer, in which the ozone is thinner. discovery of the annual depletion of ozone above the Antarctic was first announced by Joe Farman, Brain Gardner, and Jonathan Shanklin in a paper which appeared in Nature on May the 16th, 1985. Montreal Protocol. It is a global agreement to protect the stratosphere ozone layer by phasing out the production of numerous substances that are responsible for ozone depletion. This global agreement decrease in stratospheric ozone is well correlated with rising levels of CFCs and halocarbons. Halocarbons are produced by industry for a variety of uses, such as refrigerants, propellants for aerosol cans, blowing agents for making plastic foams, firefighting agents and solvents for dry cleaning and degreasing. In 1994, the United Nations General Assembly proclaimed 16th September the International Day for the Preservation of the ozone layer. A recent assessment by the UN shows it is steadily recovering. Much of the ozone layer is on pace for nearly full recover by the year 2040. The changing habits to protect the ozone layer. 1. Carpooling. 2. Public transport. 3. Walking. 4. Biking. 5. Driving an electric car. 6. Neutralize your vehicle's greenhouse gas emissions with a carbon offset. Avoiding ozone depletion products. 1. Check your fire extinguishers to find active ingredients. 2. Don't buy aerosol products with CFC. 3. Dispose of pre-1995 refrigerators, freezers, and air conditioning units properly. 4. Buy lumber, wood products, and plywood that were not treated with methyl bromide. Remember that protecting the ozone layer is not only about surviving, but also about preserving a healthy environment for future generations. Thank you for watching this fascinating topic. If you enjoy this video, don't forget to subscribe my channel.